Hello differential equation students. In this video we'll take a look at how do you solve systems of linear differential equations using Laplace transforms. The idea is very similar that whatever we have been doing all along. We can do the exact same thing that we have been doing before. First, we have now differential equations. Right now we have differential equations in terms of y of t. Rather than equations, now we have systems. Right now we have linear systems in terms of y of t. Now we have systems of differential equations in terms of y of t. Then we're going to have the systems of algebraic equations, right, in terms of y of t. But now rather than y of t, we're going to have a y of t and x of t. Since we have y of t and x of t, we're going to have y of s and x of s. And then we're going to have a solution y of s and x of s. And then we are going to transform that into y of t and x of t, right? And that's how we're going to solve this problem right here, right? And this one right here. And let's see how do we do that. So a couple of things in here before I move forward. Here, let's take a look at the system. The system that we have here is, x prime of t, x as a function of t, is equal to 6 times x of t plus y of t, and y prime of t is equal to 4 times x of t plus 3 times y of t, right? That's what the system is. Now we have, initial conditions. X of 0 is equal to 2 and y of 0 is equal to 7. And so although we don't have a t right in here, that's what we mean by that, right? So here I have to tell you that here x is a function of t and y is a function of t. So in other words, x and y are dependent variables. X and y are dependent variables. X and y are dependent variables, and they are dependent on the variable t. So here's your independent variable, and these are your dependent variables. Right, that's the general setup of this. How does this systems of linear differential equations work? All right, now let's see how do we do that. So we're going to use the same thing. We're going to apply the Laplace, and then we're going to get a algebraic system. You all know how to solve the algebraic system from college algebra or even intermediate algebra. And then using the idea, we're going to solve for cap y of s and x of s, and then we will apply the Laplace inverse transform, and then we will get x of t and y of t. And this is a very simple problem. As a matter of fact, this is a homogeneous problem. You're going to see that because there are no standalone functions of t, right? So this is a homogeneous problem. So let's see how do we do that. I'm going to keep this aside. I don't need it. So as I said, the very first step is to apply the Laplace transforms. If I'm going to apply the Laplace transforms, let me apply the Laplace transforms. Then this is going to become L of x prime is equal to L of 6x plus y, and I'm also going to have L of y prime is equal to L of 4x plus 3y, right? That's in terms of y, and this is in terms of y prime, and this is in terms of x prime. Now let me simplify this, ladies and gentlemen. Let me just simplify the x, and then I'll worry about the y in a moment. If I do this, if I apply the Laplace transform using the transforms of the derivatives, this would be s times the cap x minus x of 0, which is equal to 2. That is given as you see there. And then if I do the Laplace on the right hand side, this is going to be 6 times the cap x plus cap y, right? And then if I apply this is equal to 2, and I'm going to simplify this, right? I'm going to simplify this, so I'm going to keep all the x and then all the groups, all the x and all the y's together. If I do that, then you would agree that, I'm going to replace this by 2. So I'm going to have a sx minus 2 is equal to 6x plus y. And if I group them, you would see that I'm going to have a s minus 6 cap x minus y is equal to 2, right? So if you simplify, that's what I would have. If you do the same thing with respect to y, and this is going to be s times the cap y is equal to 4 times the cap x plus 3 times the cap y. And again, if I simplify the same way, I'm missing something in here, that is minus s of 0 minus y of 0, not s of 0, and y of 0 is equal to 7. And if I apply that, then I am going to have sy minus 7 is equal to 4 times x times 3 plus 3 times y. And if I simplify this, then you would agree with me, I'm going to have a s minus 3 of y minus 4x is equal to 7. Again, I would like to keep consistency in here, so I'm going to keep the x first and then the y as the second one. So then this would be minus 4x plus s minus 3 cap y is equal to 7, right? That is what I'm going to have. Now we have systems of linear equations, linear algebraic equations, no longer differential equations. Now we know how to solve them, right? We're going to treat as if it's a constant, right? As if it's a constant, so it's not a big deal. And let's see how do we do that. So what do I mean by that? By the way, ladies and gentlemen, here I have cap x and cap y. Here I have a cap x and cap y. And I have this systems of algebraic equation that I'm supposed to work with. So let's see how do I solve that. So to do that, what I'm going to do, I'm going to write them down together, and so that you can kind of see what do I mean by that. Let me group them in the way that it is x and y in that order. So this would be s minus x cap x minus y is equal to 2. And I have a minus 4x plus s minus 3 times the cap y is equal to 7 right there. I'm going to call this the equation number 1. I'm going to call this the equation number 2. Right? If I do that, let's see what happens. Again, you know how to solve them, right? You multiply the first equation by the, if you want to, now we are going to use the elimination process, right, in solving systems of linear equations. The way that we do that is, just multiply the first equation with the minus 4 and multiply the second equation with the s minus 6. Then x will go away, then you'll be left with y, and then you can solve for y. And if you want to solve for x, then what do? Then you multiply the first equation by s plus 3, and then the second equation, in this case, is simply 1. So you can just keep it like that, and then subtract or add, depends on what you are dealing with, and that will make the y go away. You're going to have an equation in terms of x, and then you can solve it, right? So what I'm going to do to make my life easy, I'm going to eliminate the y's, right? I'm going to eliminate the y's. So I'm going to eliminate, well, let me write it down so you know what do I mean by that. Eliminate cap y. To eliminate cap y, what I'm going to do, I'm going to take a look at the first equation. I'm going to multiply it by s minus 3. When I do that, ladies and gentlemen, what's going to happen is the following is going to happen. I'm going to have s minus 3 multiplied by s minus 6 cap x minus cap y with the s minus 3, and then is equal to 2 times s minus 3, right? And now what do I have for the second equation? The second equation I am going to keep as is. not doing anything with the second equation. If I keep the second equation as is, then I am going to have minus 4x plus s minus 3 times the cap y is equal to 7. And now I'm going to add the first and the second equation, the transformed or multiplied first and second equation or modified equation. When I do that, you're going to see that these two are gone. So y is a history now. And if I simplify the rest, ladies and gentlemen, then I'm going to be left with s minus 3 multiplied by s minus 6 cap x minus 4x, which is going to be equal to 2 times s minus 3 plus 7, right? Now if I simplify that, I let you simplify, and by the way, if I simplify this, right, this is going to be s squared minus 9s plus 18, then I have a minus 4, that's going to be 14, right? And then here I have, 2s minus 6, and then you have a plus 7 right there, right? So if I simplify all that, ladies and gentlemen, then I am going to have the following. This differential equation, this algebraic equation is going then can simplified be into, this algebraic equation can then be simplified into s squared minus 9s plus 14, 18 minus 4 is 14, right, of cap x, and that is equal to 2s plus 1 as my right hand side. Now therefore, now I have a algebraic equation in terms of x. So let me solve for x. If I solve for x, you all agree that I'm going to have my x would be, and by the way, if you remember this, I know you're all experts in factoring. If you factor this out, this should be s minus 2 multiplied by s minus 7, right? And so therefore this can then be written as 2s, I'm just going to write it down individually so it's easier to see, divided by s minus 2, let me keep it like that, s minus 2 times s minus 7. And if I do the partial fraction, ladies and gentlemen, I'm going to write it down, but it's a long process for some of you. So if I do the partial fractions, right, and then I am going to have, this would then turn into negative 1 over s minus 2 plus 3 over s minus 7. So what I have is, I have my cap x. Let me rewrite it down. I have my cap x as a function of s equals negative 1 over s minus 2 plus 3 over s minus 7. Now what I am going to do, I am going to do the Laplace inverse. If I apply the Laplace inverse of Laplace inverse transform, let me use a different color. If I do the Laplace inverse transform, in other words, if I do the Laplace inverse, this would be Laplace inverse of cap x is equal to Laplace inverse of negative 1 over s minus 2 plus Laplace inverse of 3 over s minus 7. And if you do that, ladies and gentlemen, then I am going to have x as a function of t equals Laplace inverse of negative 1 over s minus 2. If you recollect the formula, is going to be negative e to the 2t, and Laplace inverse of 3 over s minus 7 would be 3 times e to the 7t. And you do the similar process. For the y, right? You eliminate the x, right? Eliminate the x. Now then multiply this first equation by positive 4, the second equation by s minus 6, then you do the whole 9 yards just like I did right here, right? You're going to have I'm going to skip that spot, skip that part, right? What you're going to have is but I want you to do it. What you're going to have is you're going to have cap y of t. You're going to have a cap y of t, or cap y of s, I should say. No, you're going to have a cap y of s. Cap y of s is going to be 3 over s minus 7 plus 4 over s minus 2, and if you apply the Laplace inverse, then the solution would be y of t is equal to 3e to the 7t plus 4e to the 2t, right? And so therefore, if I just write it down here, let me bring this back in here. The solution for this problem is going to be these two right here. So that's how we would solve these systems of linear differential equations. I will stop it right here, and that's how we would solve systems of linear differential. The idea is the same. Again and again, the idea is the same. The only thing is that it's a process. You have to work with it. You keep on work with the Laplace and Laplace inverse, and then so on. Then you should be able to figure it out nicely there. And somebody had a question about homework 13. After watching the systems video, by now you should be able to solve this problem, and this problem as well. That's what I solved, by the way, on the video. And this problem, you should be able to write down the systems for this one, and then you should be able to solve it. And this one, and you should also be able to solve this, and this. And these problems, of course, require a few other things. These ones involves integrations. You will see that in a moment in the next set of videos. And these two also requires integrations, and this requires piecewise functions. This also requires piecewise functions, and this also requires piecewise functions, and this also requires piecewise functions, that we will see in the next set of videos.